Hello everyone. In this video, we'll continue with the UDD fractional age assumption with examples related to the life tables. We have already covered all necessary expression under the UDD assumption. And then we now work with an example involving life tables. All right, given the following life table, either you will be asked to use the table given in the exam, or you may be given a life table. Okay, for example, I just take these two columns out for this question. And we will be answering the calculation of these 6 quantities, given that the fractional age assumption under the UDD assumption. Okay, so the first quantity, L68.25, we simply make use of the fact that, okay, we are dealing with fractional age, and this fractional age here is 68.25, where S is equals 0.25. So we have Lx minus S times dx. We are working with L68.25. This is L68 minus 0.25 times D68. And D68 is L68 minus L69. From the given life table, we have the two L's, L68 and L69. And then plug into the expression. And we get the expected number of survivors at age 68.25. All right, the force of mortality, mu 68.25. The corresponding expression for that is Qx over 1 minus S times Qx. And then you know that Qx is related to dx, and we can make use of the life table to calculate the Qx. Okay, so we have x is 68 and S is 0.25. To get Q68, which is L68 minus L69, which is D68 over L68. Again, from the life table, we get L68 and L69 respectively. So we have Q68 is 0.008297. Put it back to the expression for the force of mortality at this age. And then we get mu 68.25 is 0.008314. The next quantity, 0.45 Q63. And again, we are dealing with fractional age S equals 0.45, which is less than 1. So this SQX is simply S times QX, where S is 0.45, and we need to get Q63. Q63 can be expressed as D63 over L63, and D63 is L63 minus L64. All we need is the L's for the age 63 and age 64. So from the life table, do the substitution, and then we get the desired probability, 0.0021. All right, the next one, 0.3 P 65.2. All right, so this probability equals, in terms of the L's, is L 65.5 over L 65.2. The expected number of survivors at age 65.5 over the expected number of survivors at age 65.2. From that, we can make use of the expression here. The fractional ages, the fraction is between 0 and 1. The S is 0.5 in the numerator, and S is 0.2 in the denominator. All right, we can get L65 directly from the table, and then D65 is L65 minus L66. We only need the information of L65 and L66. We get D65 is 559.4. Plug this back into the expression with the L65. We get the corresponding probability. The next one, 6.8 P61. All right, I'll apply the interpolation formula. And this I'll express as x equals 61. So the denominator is L61. And then we have t equals 6. And then s is 0.8. So the numerator, we have the interpolation formula, 1 minus 0.8 L67 plus 0.8 times L68. We can get L61, L67, and L68 from the table. And then the rest are straightforward. So we get the answer, 6.8 P61 is 0.9641. The last quantity, the deferred mortality probability, 2.1 bar 4.3 Q 61.6. All right, express this as the difference of the P's, 2.1 P 61.6 minus 6.4 P 61.6. And then express as the first term, L 63.7 over L 61.6. And then the second term is L 68 over L 61.6. All right, we need to deal with the fractional ages. Using the interpolation formula, L 63.7 is given as this. The interpolation between L 63 and L 64. And then we get this. L 61.6, interpolation between L 61 and L 62. We get the corresponding value. And then together with the value of L 68, then we can get the probability upon substitution. We get the answer 0.0261. All right, you can use any appropriate expression to compute any of these quantities. Okay, so my way may not be the best. Okay, but this is just a demonstration for you. All right, so these are an example. This is an example related to calculating the probabilities, okay, using the live table. And this is everything regarding the UDD fractional age assumption. In the next video, we will be going into another fractional age assumption, the constant force of mortality. Thank you and see you in the next video.